push and pull. If you're interested in information technology, the idea that sometimes you have to pull information out of a system. You have to physically go to the internet and search for information. In other types of communication systems, it's pushed towards us. Things like reverse 911 would be a great example of push. Things like CMAS, if you're familiar with that, is an example of push. These are things that are lurking on the horizon, CMAS. 40 character limit, including spaces, but we'll talk about that later. So in terms of metrics that we need to address, one thing that we could do is we could look at how these different solutions are being used. Again, what's being used, what's not, and why. What are the costs? And we actually have to ask about availability as well. So if we continue looking specifically at pre-planning for post-recovery, we have to start asking ourselves about the information that's available to us. One thing that popped up was the idea of training. One of the local ladies here from Alabama talked about the idea of training school children to know about where you can go for help. Oh, 1 minute left. So what we need to do is we need to know what's effective. We need to look at needs assessment. And looking at different levels of the community, we specifically need to look at metrics for recovery, as I mentioned earlier. How rapid was recovery? How economically viable was the final community? If a town were hit again, what would be the likely outcome? These are all things that could be assessed and measured. Last but not least, a lot of us were operating on the assumption that rebuilding was the default option. Are there instances where we need to tell people, no, perhaps moving away would be better? So those are situations that we need to discuss for future disasters. Specifically, before I run out of time here, got some bullets from safe rooms and shelters. Specifically, we've been operating on the assumption as well that forecasting is going to get better, technology is going to get better. What that suggests is that if all these things are improved in the future, maybe we could buy ourselves some more time. We've been operating under this assumption that with a tornado, we're talking about sheltering in place. If we can improve forecast where we have a little bit more lead time, it makes it possible that some people may actually evacuate to a community shelter. So that's something that we need to consider. Also, we need to think about different barriers to implementation. I talked about this a little bit earlier, specifically with finance. We talked about residential workplace as well as community shelters, differences between those different types of construction. But a number of things we also addressed were the idea of liability. One thing that always pops up is if you have a shelter and someone else doesn't, are these people going to be able to stay with you? And if they get injured, if the shelter fails, are you now going to be liable? So that's another situation that we addressed with this. So pretty obvious metrics here of cost, number of people protected. I'm way over time, it looks like, so questions?
It's come up in a, well, you mentioned it and it came up in the physical scientists group meeting earlier today about improvements in lead time. And I guess there's a figure that originates with Harold that shows that lead time actually hasn't changed in about 25 years if you throw out the cases in which there was no detection. In other words, the upward trend in lead time is a bit misleading because it's really reflecting better detection. But for those that are actually detected, lead times haven't changed. Is that right, Harold? So that 25-year period includes the installation of a Doppler radar network even. So I think, to me at least, it seems a bit far-fetched that we would expect much improvement in lead time from here on out if the 88D network itself didn't really help a whole lot. It's just food for thought.
It's interesting because I was actually thinking about a response to this gentleman's question earlier about have we hit a ceiling? We've seen all these different declines in fatalities, at least up into the bump last year, it sounds like. Have we hit a kind of a ceiling where we can no longer improve? And it sounds like you're saying something very similar. That's with the technology. If you're thinking about warning interaction as a systems approach, something that includes both the context, obviously the disaster, but also the person as well as the technology. What we really need to focus on then is compliance. We've done all we can do from the technology end. Maybe we need to start thinking about what we can do from the human end. How do we get people to comply faster? How do we develop these PAR recommendations where people can respond faster? Great food for thought. I need to digest it a little bit more.
I was in this group, and you answered it very well. The only other thing I would add is you can almost change the question, the research question to say, if you could improve the lead time, what additional options could you do? And maybe that becomes more of a goal or something to shoot for from a compliance standpoint, from a technology standpoint.
Right. $1 million question.
Okay. Thank you, Chris. Let's move on, and we have one more group, the red group. Jeff Lazo. There's your dot to advance.
Dot to advance.
And that's your computer deployment when you want to advance.
Thank you. And you're the one who's going to tell me when to do it? I'll give you 2 minutes. Okay, I think not sure if we followed the instructions, but we didn't put up here, we were the economics group. Actually, I know we didn't follow the instructions. I'll see why in a few minutes. So we went around quite a bit, had a lot of interesting discussion. I'm not sure we, at the end of the day, came up with the prioritized list, but I think we'll come back to that over the next couple of days. We decided to frame a question with this of, what is the optimal allocation of resources to reduce the societal impact, including loss of life, because that's not the only metric that's been measured or talked about a number of times here, from tornadoes. And instead of just jumping in, I also want to kind of lay the groundwork from our point of view, my point of view as well, that what economics can do, what economics can bring to this. There's 2 things, and this may be something of generalization, that 2 uses most people seem to see for economics. The one that comes up the most is program justifications. We're going to put a dollar value on this to justify it to Congress or to the guy upstairs or the guy over at OMB or something, which includes, justifying current programs, investments in future programs. We use tools like cost-benefit analysis for doing this. You've probably heard of most of those. The other, and from a kind of more interesting researchy side, is the idea of economics as the study of behavior and decision making. And I think that I'm putting words in our group's mouth, but that's fine because they're welcome to throw things if they don't like it. I think the top part, the program justification, is maybe of significant interest to NOAA and potential funding for NOAA. I think the bottom part in terms of studying behavior decision making is actually maybe more towards of interest to somebody like NSF. The NSF probably is not interested in program justification, but I'm not going to put words in Denny's mouth at this point either. But in terms of studying behavior, economics is just not putting dollar values on things. It's talking about decision making, trade-offs. It's closely related to decision sciences quite often. And it's not just valuation. We actually put a graphic picture in. I think we're the only one that did that. We did not follow instructions. And we skipped the whole slide about gaps and stuff like that. But what I think we wanted to do is say, what is the system we're talking about? Where does economics fit in here? This is a graphic from a paper on developing a social science research agenda for the THORPEX program, if you're familiar with that. But the idea is that the forecast system is quite broad. And this actually isn't even broad enough because this didn't include things like land use planning and emergency response and things like that. But trying to think about this from the whole system, all the way from weather to OBS to forecasting to communication to use decision making, and actually valuation for the most part comes at the end. But along the way, we'd say that there's value added or potential value added at any one of these points. So it's not just value added by improving accuracy, but all the value added, if we're not going to improve accuracy, there may be a lot of value added potential for adding value just by improving the use of the communication and decision making. The other thing we pointed out is in terms of this verification part, it's also time to move from the standard kind of meteorological based metrics for verification to kind of a user relevant societal approach to verification, user relevant verification. And economics can be a tool for that, or can bring tools in for doing that as well. And that's an area that when you start thinking about it and start trying to do it is very much more difficult than we first think about in terms of user relevant verification. So jumping ahead, we skipped the whole gaps thing and just went recommendations. But and again, some of these are very broad, and these end up being broken down to two groups, kind of the valuation studies, which kind of line up a little bit more with program justification, and four major areas there. And I think the point was here when we said, what are the gaps? And we just kind of said everything, that there isn't a very broad or deep body of knowledge on the economics of any aspect of this. If there are any studies on anything, they're one-time studies, so they have not been replicated and they have not been verified, which as physical scientists you think are critical. In social science that's true as well, but it's rarely done, and I think we need some more of that. But again, the kind of four general areas: economic impacts of tornadoes. There is some work on that, but there's still potential for a lot more there. The value of the current forecast system. This is actually a much more difficult question than you would think. What's the value of the current system? Well, the option is not having the current system, so how do you value that? How do you make that comparison? But that also could be of critical value to, say, decision making and going up to the Hill to justify the NWS as it is now, say. Value of improved forecast system. I think this is the one that probably resonates the most with say, policymakers. How do we justify investments in improving the forecast system? So what's the value of reducing the false alarm rate? What's the value of improving probability detection? Again, when I say the forecast system, we're talking about the whole system, not just the weather forecast product. We're talking about the communication, use the whole thing, potential here. And then finally, the fourth one, value of research to improve the forecast system would also be useful. So if you're going to go spend, I don't know, 200 million, is that even right, on, say, MPAR, on phased array radar, you're probably going to need some idea of what the value of investment into creating that research, into doing that research, and economics can bring that. And the items in blue here are ones we tried to pick out of the 7 high points out of the Norman meeting in terms of economics can feed into all aspects of this. On the behavioral study side, economics, if you forget about dollars and just about decision making, trade-offs, economics can bring a lot into understanding risk-related decision making. We deal a lot with decision making under uncertainty, so we have tools, methods for that as well. Communication is one we highlighted here. Economics can talk about decision-making, communication, how people use information. Economists think, and we do this in our research, work with communication, integrating theories and methods across these to look at behavior there. The last bullet point you threw up, say, economics, economists, we have a fairly cohesive model that most economists, our basic understanding is pretty consistent, but we think we can integrate that with models from other areas. The pattern model that Mike talks about, you can see some real ways, maybe we can bring what we think in terms of modeling and theory to integrate with, say, decision making with communication models, and there's a lot of other communication models there as well. With that, this, I think Linda said this very eloquently, we would also advocate a much broader, integrated, long-term, in-depth social science research program that is not just these one-off grants that maybe never get used, but there is a broader community that synthesizes this and makes sure that this is used. We had talked, so the tornado economists don't know what type of data, say, the CDC has, and some type of way to integrate that and facilitate that. We get probably a lot of benefit just by using the knowledge we already have better, as opposed to a lot of new work. And there's also, this is very incomplete, data needs that we need for economic research. Economic data is much sparser than weather data by far, so there's a lot of data needs there, just information we'd want to be able to answer the questions we have. And with that, I think that's it. And my fellow group people will be happy to answer all your questions.
Well played, well played. No, don't walk away. Run. Yeah, run fast. That
Hey, Chuck.
I want to mention what I consider to be a gap that perhaps you chose not to address, but essentially the information we have about the economic impact of tornadoes is essentially the cost of the buildings damaged and destroyed. It's like saying that the economy of a community is measured solely by the single number of the value of their buildings. My perception of the impact of tornadoes on communities involves a lot more complexity in the economics of that community. What's the effect of the tornado on businesses? Some businesses are closed and may pack up shop and go away forever, extracting their business from the community. Other businesses may prosper, like those in rebuilding homes. And virtually none of this is accounted for by the measures, the metrics that we have. And I've been trying in vain to stimulate economists to tackle this bigger question. Another topic would be, we have all these people traumatized by the storm. How does that play into the rest of their lives? Some of them may be so traumatized they lose their jobs and so on. So then you have another person who's unemployed, and et cetera, et cetera. It seems to me that our understanding of the economics of tornado impacts is really, really primitive.
I don't disagree. So, yeah, I think economists, we have tools for doing that. We have methods, we have the theories. There are people that do somewhat similar work, say in earthquakes and say long-term recovery using computable general equilibrium models, regional economic models, that type of thing that can look at the dynamics over time. As far as I know, there's been virtually none in the tornado area. That's not just tornado, that's pretty much all weather impacts. And we've actually looked at this, how the NWS gathers the storm data process is pretty arbitrary. What's that? Okay, straight from someone who enters the data, and try to say, is there better ways to do it? Yes, there are, but until there's funding and resources and time to do that, it's not going to happen. You know, the impact of hurricanes, they ask the insurance companies and multiply it by 2. That's all the other damage from weather incidents is done a different way. So it's arbitrary and not quite as good as it should be. But I don't know, it's better than nothing, somewhat marginal.
Harold, let me give a shout out to people who have supported me in Tuscaloosa and Joplin, and that is all the NSF program managers in the room. We are very grateful for NSF rapid support, which got us out there within days. The money showed up a little bit later, but we were out there, and we have data. If anybody is willing to share and go to my website and call me for probably 1,300 homes that we actually looked at, investigated, understood the damage, how it failed, and we did the same thing in Joplin, sponsored by the American Society of Civil Engineers and the International Associations of Wind Engineering, so that we are there in the front line. We've been doing this from the point of view of hurricanes for a very long while, and now all it's needed is for you to recognize my face and I to recognize yours, and it's a phone call away. I mean, literally, that's how it started. We went out to Tuscaloosa simply because I looked around Gainesville and I thought, my goodness, these homes are the same. They're in the same location relative to the university, and we would have had the same issues here. And so it's beyond you know, this larger organizational thing. It's going to come down to real just people in this room understanding that they can work together and just move this forward.
Yeah, following up on the data item, it's a much broader question than just the economic data for all of us, and certainly in the research community who've gone out and captured disaster data in the past. Most of it probably just sits on the hard drives of the individual faculty members researchers who've collected that, and maybe some industry or agency groups have some more collection of data. And I know certainly when I was at LSU, we had a pretty significant effort after Katrina with some FEMA funding in LSU put in to develop many terabytes of data to get some of the Katrina data together. But recognizing this problem, maybe some steps in the right direction. NIST stood up a new program last year called the Disaster and Failure Studies Program. And as part of that, a colleague of mine, Eric Letvin, is leading a series of pilot studies to create a disaster and failure events repository. And so that would be a system that's potentially, when it's finished, broadly accessible, where we can take data from many sources, whether it's disaster data, the Met data, meteorological data, forecast data, damage data from buildings, as many different sources as you can imagine. Some things have personal information that wouldn't be available, et cetera, although they may be used for NIST internally in the investigations. We have a pilot study going on right now, actually, for the Chile earthquake that NIST participated in the investigations of, and we're using our Joplin study right now for the beginning of the third phase of this disaster and failure studies repository. So ultimately, that might be a tool to be able to get everyone to share data and have it broadly accessible across the whole community, the full range of data. Other thing is, while I'm just mentioning and talking about the data, in the very first presentation, there was, I believe, the last bullet that talked about more detailed, perhaps field investigations and something like the NTSB, the National Transportation Safety Board. And maybe you don't know, there actually is an existing statute called the National Construction Safety Team Act, which gave NIST the authority to do investigations after building disasters. It was modeled to some extent from NTSB, and we've done investigations on the World Trade Center, the Rhode Island nightclub fire several years ago, and our Joplin study is being done under that specific statutory authority. So NIST already has that. And perhaps the other thing that relates to that is there's legislation pending in both houses of Congress right now that would reauthorize this National Windstorm Impact Reduction Program, which is a joint effort of NIST, NOAA, NSF, and FEMA. In that pending reauthorization, there's language that would move the lead agency function to NIST and give NIST the lead agency function for coordinating all federal post-windstorm disasters. So at least, I know that's on a list, there is actually some activity moving in that direction, so we may be able to get that, assuming that there's a lot of differences between the House and Senate bill, but that the moving lead agency status to NIST from where it is right now in the White House Office of Science and Technology Policy, for whatever reason, but moving that to NIST and giving NIST at least one agency the authority to coordinate all of these investigations plus the NCST, that may very well go towards addressing that last bullet in that first presentation, and then our existing effort to stand up this disaster and failure events repository may be an element that would help support some of this data sharing.
We're starting to drift into the general discussion. Is there a specific, Jamie? Yeah, I actually got
you can't ask questions, Jamie.
She's answering questions.
Okay.
Oh, I was going to give a response.
Okay, good.
Okay, actually two of them. One of them is to sort of go back to when the discussion was we need to sort of categorize all the different flavors of social sciences that can contribute. I'd like to refer you to the social science working group that wrote 2 reports to the Science Advisory Board that spent quite a bit of time characterizing a lot of the ways that the social sciences can contribute to this discussion. So that's number one. Number two is we had done in response to Mr. Doswell, we have done some work looking at time series employment trends that were associated with some of the tornadoes that occurred around the turn of the century, this last one. And this last turn of the century is 1999-2000, Oklahoma City and Fort Worth. And what we found was, and I want to qualify this because aggregate economic measures do not capture some of the really important effects that happen to some disadvantaged populations. Okay, but what we found was after a short dip in employment, the employment actually increased. The rate of growth in employment was, for the most part, stronger and more stable after the tornado than before. So these results, to me, create a real interesting conundrum that I think hopefully in the next 10 years or so we'll be able to sort it out to understand it better. But there is, nobody wants a disaster, but by some of the economic measures, it somehow jumpstarts some economic measures. Yeah, so I want to qualify that a lot, but it's really interesting actually that you get this.
Did you get into at all individual adaptations to tornado risks, such as safe rooms, mitigation, preparedness, and so on? Because my concern is, given a very low probability event at the individual level, household level, one could come to the conclusion that nothing is really cost effective or rational to do. So that while this is a national problem, and for states in the Southeast and the Great Plains, it's probably a state issue. At the community and individual level, it's hard to come up with economically rational courses of action. And as a result, nobody does anything. And maybe not doing anything is what should occur.
We started doing bullets of things that could be done, and after about the third slide, we realized we could have dozens and hundreds of bullets on all the things that we could look at economically. That would be one. What's the benefit cost of putting a $6,000 safe room in a $12,000 trailer that has a 1 in 50,000 chance of getting hit by a tornado in the next 50 years? But economists can do that if you want to hire us to do that. We actually come more expensive than most other social scientists, but no, we actually backed off starting to trying to itemize every possible question because it starts being overwhelming. The other thing I started worrying about is whichever one we get hung up on in a particular point is the one that becomes the point and becomes the priority, even though if we did the same process, there might be 20 others that come up. So I think we have painted a very broad brush because there's such a broad range of questions that could be and perhaps should be answered. So.
Any more questions for Jeff? Okay. Why don't we turn now to in the somewhat limited time before 5 o'clock, why don't we turn now to the general discussion, and what I'd like to encourage people to do is to raise questions or raise issues that go across the different groups. I'd like to get sort of people warmed up for the ideas of what we're going to be doing in the interdisciplinary groups tomorrow. So does anybody, there were a number of points in the presentations about the individual groups, about the disciplinary groups, in which people talked about topics that got picked up in other groups. So does anybody want to continue with some of those questions or some of those issues? It's the 4:30 phenomenon. Okay, we got one over here. Get to you.
Just in terms of moving to cross-disciplinary perspectives on the issue. I think from the research that I've done, an outstanding question for us to researchers in the field from all different perspectives to try to think about is the research shows that tornadoes in the southeast, everything else equal, are deadlier than in other parts of the country. And that holds up, controlling for warnings, the strength of the tornadoes, a whole raft of different factors you can try to control for in a quantitative analysis. And I think that may be one sort of organizing theme given where we're at here, and to think about from all of the different perspectives, whether it be the meteorological perspective, if there are differences in the types of storms that we have, if there are individual level responses, if there are engineering differences, if there are vulnerable populations differences in the southeast versus other parts of the country. But I think that's an open question, and maybe that's one to just throw out as a way to begin some of this cross-disciplinary discussion.
Does anybody want to follow up on that? Okay.
Yeah. Actually, we're about to, some colleagues and I are about to undertake a study attempting to do pretty much what you've described. I think there are some factors that might well account for some of that, some significant portion of that variability, and we're going to test those in the typical sort of, we'll build a model and see how much of the variance it accounts for, and we're going to see what we find. I think there are at least some ideas floating around about why that may be the case, and so we're going to test some of those. So I'll be sure to keep you informed on our progress. Not as a follow-up to that, but as a topic that obviously showed up in a lot of the presentations was the issue of false alarms. And I think I'm sensing a fairly broad consensus in this group that we need to spend a fair amount of time emphasizing work that's going to shed some light on that topic. So hopefully one of the things that comes out of this will be some perhaps agreements to collaborate on that kind of topic.
Ray?
I wanted to bring up the point that in the 1970s and the 1990s, NSF funded multi-$100,000 worth of and multi-year research needs assessments in the natural hazards field. It's in my face, it's just not picking up. Anyway, to repeat what I said, in the 1970s and the 1990s, the National Science Foundation funded multi-year, many hundreds of thousands of dollars research needs assessments related to natural hazards to accomplish basically what we're trying to do in 3 days. And so it strikes me that one of our recommendations should be that NSF or the Weather Service or another organization fund a similarly large-scale effort that brings in the whole array of people we noted that aren't here today, and so that this is really comprehensive and in-depth, et cetera, et cetera.
But we're so much smarter now. Okay, other questions or comments? Yeah, over here, Jamie.
Hi. I'm going to argue a little bit. I think restricting ourselves to just looking at false alarms is not describing what we should be doing. I think there's a whole bunch of ways we can use the meteorological information. I always have trouble with that word. And it boils down to sort of what you have as far as the accuracy and what you do with it. And so when you decide to call a warning based on whatever accurate information you have, then of course you know the trade-off between type 1 and type 2 errors is what's occurring here. So I would say we need to think about what do we do with the accuracy of the information we have, including deciding how large the warning area should be, how long the warning should exist, when should we release people from being in some kind of a safe area, and add that to lead time. And so there's a bunch of things. I don't think we should just restrict ourselves to just false alarms.
I didn't say or imply that was going to be the sole topic, but it was certainly a topic that came up in a lot of the presentations. And the real issue is that, I think somebody said it very well, the Weather Service has a clearly defined metric for false alarms, but we have no understanding of how the public perceives that same metric. And so we are desperately in need of information about how people perceive events. If we're going to take that into account properly, we have to know what they think is a false alarm. We don't really have a clue what they think. Well, there are lots of ideas floating around. Ideas are a dime a dozen, but hard research and data is a whole different issue.
Sort of on a different topic, I think one of the strongly motivating factors for this get-together is in the chart showing the apparent or possible bottoming out of reduction in fatalities from tornadoes. And I think it would call for a strong interdisciplinary look at the mechanisms behind that, if it is in fact not just a sporadic change in the trend. Because there's a lot of factors going on that would yield to interdisciplinary work. For example, we have an increase in human population. We have shifts in rural versus urban residency. So an expansion of suburbs. There's more people living in areas. There's going to be more tornado intercepts with human populations. There are more people moving and relocating without having had previous tornado experience to tornado zones. So there's a whole myriad of factors that may be pushing against that reduction that have nothing to do with improvements in forecasting or warning.
Right, and one of the possibilities is it could be that what's happening is that there's an increasing variance in the outcome. So the mean's being depressed, but the potential for a catastrophic outcome could be increasing. Other comments?
A little bit of a hop, skip, and a jump here. Back to false alarms. In Aesop's Fables, The Boy Who Cried Wolf, it wasn't called a false alarm, it was called a lie. The modern concept of a false alarm comes from signal detection theory, and in its one of its original applications, radar in World War II, a false alarm is when an operator says that there's a plane there at a certain place, at a certain time, and in fact there was not a plane there. What we have now is a multi-headed hydra. There are many meanings. False alarm is perhaps a misleading phrase. They need to be unpacked. They need to be investigated from the standpoint of the intended meaning and understanding of the forecaster, the intended meaning and understanding of the consumer, whether it's the public or a core partner. And that's a big piece of fruit. Parts of it are low-hanging, parts of it are way up high on the branch, so it's like a banana, it's a long fruit. But I agree that that's something that's got to be researched quite intensively. But I don't see that that's necessarily at odds with what you were saying. I think you're both right. That's what originally triggered this thought.
Yeah. Joe Trainer, over here.
I've heard a couple people mention this idea of bottoming out. And it's interesting to me, I think, and it brings up something that concerns me a little bit. And I think that's the idea that social science might be able to come in and provide a rapid solution and put that trajectory back on, where all of a sudden we'll see a huge spike all at one moment. That maybe we'll see some kind of silver bullet solution emerge from a meeting like this that'll cut or that'll double response time or double response compliance or somehow we'll really understand how to get people to do the things that we want them to do. And that concerns me to a certain extent, because I think more than anything else, what we're seeing here is ideas pop out and focus go to different issues that are kind of like the low-lying fruit. The idea of false alarm is something we can all get behind, or lead time is a great concept, or geographic specificity. These are things that we can grab onto really easy, and we hope that those will solve it. But I think that one of the things that we really need to start thinking about in a large group like this is that these are complex problems, and that any solution has both intended and unintended consequences. And what I think we really need to start doing is starting to understand how we leverage our understanding of the complex environment towards new solutions and new understandings of old problems in a more meaningful way. We use this term, I think, in our group here, that sometimes it looks like we're trying to use social science to create weather-ready zombies who automatically respond when we flick the screen and their eyes go white and they go right to shelter because we told them to, and that somehow is going to make them better because they're safer. And I think that we don't know how to get to that solution, and I don't know that we want it, even if we could. So I just want to just try to think about how we can think more creatively or more outside of our normal patterns to come up with more complex solutions rather than trying to find simple solutions to complex problems.
One thing I think we're finally grasping with this question, Joe, of the complexity of the problem is that it took us a long time to get here, and it'll take us a long time to get out of here. In other words, we have built the homes that we saw failing in Joplin and in Tuscaloosa. They were there from the 1950s, 60s, 70s, and 80s. These are old homes. We did talk in our group about the number of rental property and the lack of maintenance specifically in those types of situations. I think what we ought to be looking at is not what we want to do tomorrow or the next year, but what kind of community do I want to live in with my family in 25 years, in 50 years? How long do we wish these communities to remain? And then we put this tornado susceptibility or resilience in the broader context of sustainability of our country and the resources that we spend here. If we only focus, as we are doing here, on the disasters and not on the living and the life of that community, we will be missing the point, and I doubt anything that Dan or the other economists can do will come to the point when the money is going to balance. But if we get to the point where we say we want a community that's survivable into the future, what does that mean as our populations increase and risks also increase?
One last question.
Not a question, but you ended the statement with risk, and I think risk identification and acceptance, whether it's known or unknown. Folks choose to live where they live, and there's a certain risk involved. And if they are aware or not aware of the risk, obviously there's protective measures that people can take, and a better understanding of why certain people, if they have the means, can take advantage of those protective measures, and why some folks that have the means don't, and what can be done for those folks that don't have the means and want to take advantage of those protective measures.
Okay. Okay. Erica over here. See, I threw you a head fake to get you that direction.
I think I was in the group talking about individual and household behavior, that the kind of the word problem keeps coming up, and I'm getting confused because I'm not sure, and I'm wondering if everyone's talking about the same thing. Are we talking about economic losses? Are we talking about number of homes destroyed or the money associated with that? Are we talking about misplacing people and having them not be able to have homes or a place to come back to? Are we talking about fatalities and injuries? Is that the problem we're trying to solve? Are we talking about people moving or sheltering and they didn't have to? So I think what would be interesting to talk about either tomorrow or the next day is, what are we trying to actually solve? I mean, Mark stood up and said, we're trying to solve fatalities and injuries, but I'm not sure that's what everybody in this room is talking about when they use the word problem.
That's a great ending for today's session. Tomorrow, remember, we start at the Continental Breakfast at 8:30, not 8 o'clock, and so we start our interdisciplinary discussion groups. That's at the Middle Star. We start those at 9 o'clock. The Continental Breakfast is room 414, so remember, do not come back down here in the morning. It'll be up on the fourth floor for the breakfast and for the discussion groups. And Harold, anything more? Bill, anything more for today?
Be ready in the morning to pick up your thumb drives at the breakfast area, group leaders. And tomorrow there'll be 2 group leaders per session, a physical scientist and a social scientist. So that should happen. And
with that, we're done for the day. Bon appetit.
Could the social scientists briefly come back and touch base with me back here in the corner? Thank you.